Hello everyone, welcome to Pre-Calculus. This is Mrs. Kostlecki. Today we're going to work on how to find our trig ratios when we are given a ratio. This little diagram right here can be really helpful because we have to understand the signs for each of our quadrants. It's going to be really important in this section. So here's another diagram that has the signs. We've got sine and cosine on this left coordinate plane, and then we have tangent on the right. So something new. When we look at our coordinates on a coordinate plane, our x value is always our cosine, and our y value is always our sine. Also, tangent is equal to sine over cosine. So that means when I have a point over here, so let's say I have a point in the second quadrant, because my x value over here is negative, that means that my cosine is also negative. And then my y value, since it goes up, is positive. That means my sine in this quadrant is positive. So these go hand in hand. Over here for tangent, if we have a positive tangent, that's because we have a positive sine divided by a positive cosine. Over here, our tangent's positive because we have a negative sine divided by a positive or negative cosine. So negative divided by negative gives us a positive. Over here, we have one negative and one positive in each of those, or in each of these quadrants, sorry. So that's why we get a negative tangent. How this works is when we're given a ratio, first we do is draw the reference triangle. Then we have to label our sides. Don't forget about your negative signs, and use the Pythagorean theorem to find our missing sides. So these are the three steps that we have to do. It's a little bit tricky sometimes to draw the reference triangle when you're given a ratio. So if I have 5/12, if this is my problem, I'm going to draw my coordinate plane. It doesn't have to be anything fancy. Since it tells me it's in quadrant 3, I know my reference triangle has to be here in quadrant 3. This is my reference angle, and I know that tangent is 5/12, so that means my opposite has to be 5, my adjacent has to be 12, and since this went left, it's negative, and this went left, it's negative. My hypotenuse right here, if I use Pythagorean theorem, it's going to be 25 plus 144 equals 169. Take the square root of that, and I get 13. So here's my triangle. I knew it was in the quadrant 3. I fill in using my ratio and Pythagorean theorem, and now I can find all my ratios. So the sine of theta is going to be opposite over hypotenuse, negative 5/13. My cosecant of theta is going to be 13 over negative 5. Cosine of theta is going to be my adjacent over hypotenuse, so negative 12 over 13. And my secant of theta is equal to 13 over negative 12. Tangent we already have, so I'm just going to write that down. That's 5/12, which means cotangent is 12/5. Notice that all of these signs are, they mesh with these diagrams right here. Okay, so we need to always be cognizant of that. Sine over here, remember, is my y value, so that should be negative because my y's down here are negative. Cosine should also be negative because I went to the left, so my x values are negative. And then tangent's positive because sine over cosine, it's both negative divided by negative, which gives us a positive. And then whatever sign you have for sine, that's going to be the same for cosecant. Whatever sign you have for cosine, it'll be the same for the secant and the same for tangent and cotangent. So this is the first type of example you're going to see. The next one, we have to do a little bit more thinking. So if I draw my coordinate plane, first I know that tangent is negative. So if you recall, tangent is negative here and here. So I know that I have to be in either of these two quadrants, but I need to narrow it down to one. So the other step is I look at this. If it says sine is greater than 0, that means my sine is positive. So remember that sine is your y value. Where is y positive? Up here or down here? This is going to end up being in the second quadrant. So this is where tangent is negative and sine is positive. So now I use this ratio right here. Here's my angle, theta. And since it's tangent, it's opposite over adjacent. So I get 4 over 3. So that's opposite and adjacent. This is the one that's negative because it's to the left. This is positive because it's up. And then when I use Pythagorean theorem, this will be 16 plus 9 equals 25. The square root of 25 is 5. So now what I can do is find all my ratios pretty quickly, actually, after I have that reference triangle drawn. So sine is going to be opposite over hypotenuse, 4/5, and that means cosecant is 5/4. Cosine is going to be negative 3 over 5, my adjacent over my hypotenuse, which means secant is negative 5/3. My tangent, I actually already have, because that's what I was given, negative 4/3, and that means my cotangent is negative 3/4. It's always a good idea to double check this though. Is my tangent actually negative 4/3? Well, it's 4 over negative 3, which is negative 4/3. So those are my 6 functions. The toughest part is just understanding which quadrant to put the reference triangle in. In this last example, we're going to draw that coordinate plane again. And we have to think sine, this is my y values, cosine, this is my x values. Keep in mind, cosine and sine, they're alphabetical, just like x and y are. So cosine goes first, that goes with the x. So if my y values are negative, that means I have to be down here or here. This is where my y values are negative. My cosine, though, is greater than 0, so that means my x has to be positive. So my x values are positive on this side to the right, so that means this cosine is going to be positive, this one's negative. So I will draw my reference triangle right here. Now, since sine is negative 2/5, that means my opposite is negative 2, my hypotenuse is 5, and this one I have to do the Pythagorean theorem where it's 25 minus 4, since this is the hypotenuse. I'm not really showing my work here, but this would be like 4 plus b squared equals 25. Then you'd subtract the 4. So this is going to give us 21. Take the square root, and this is the square root of 21. Now, when I go through and I do my ratios, I just have to be careful with that square root. So sine is going to be opposite over hypotenuse, so negative 2/5. That means my cosecant is negative 5/2. My cosine is going to be square root of 21 over 5. My secant is going to be 5 over square root of 21, but remember we have to rationalize that by multiplying the top and the bottom by square root of 21. So this will be 5 times the square root of 21 all over 21. My tangent of theta is equal to my opposite over my adjacent, so negative 2 over square root of 21. Again, we have to rationalize that. So negative 2 times square root of 21 all over 21. And then my cotangent is equal to this flipped, so square root of 21 over negative 2. So that's how we find our trig ratios, all 6 of them, if we're just given one ratio to begin with. Either we have to know what quadrant it's in, or we have to have enough information to be able to tell which quadrant it's going to be in. This right here is super helpful, so make sure that you understand this right here. It's very important that we understand cosine is our x, sine is our y, because that also helps, and that tangent is sine divided by cosine. Okay, thanks for listening, take good notes, and then we'll go over more in class.